Hey, P Statistics. So we're going to jump into Chapter 5 today, probability. In this section, we are going to learn how to do just a couple of things. We're going to make sure we can interpret probability as long-run relative frequency, and then in the second part, we'll use simulation. So let's just get to that idea of probability. So probability is the idea of anything that we're dealing with chance behavior that's unpredictable in the short run, but has a regular predictable pattern in the long run. And so, our classic things are like flipping a coin or something like that. In this case, we're talking about a proportion of heads. As we flip a coin in one given flip, we have the behavior is unpredictable. We don't know what the result is going to be. There's uncertainty. If there's certainty involved, then then we're not talking about probability. But if there's any uncertainty involved, so your classic dice and so on, but we can get outside that as well. So in the short run here, it's really unpredictable. We don't know whether the first one's going to be heads or tails. We don't know the second one's going to be heads or tails, and those are independent. We'll get into this idea where after I flip the coin, it doesn't affect the probability going forward. So every single flip of that coin is unpredictable. However, and so we can see this here in this original chart, we see that over the short run we had a head. So then in the first flip, 100% of our flips were heads. On our second flip, it ended up being 50-50, and then we had a heads and then tails. And you basically, when this thing's going up or down, is when we're getting heads or tails. So it's unpredictable. But what happens eventually over time, and so you can see this in the second one, over the long period of time, it starts to get settled out into this very predictable. It's going to end up being in a coin flip at least 50% of the time, right? So we have our first 10 runs versus long term, those 500 flips. We start to get very close to, and that will always happen if we repeat this process. It's going to be over the short run, it's unpredictable, and even still, if I start at that 500th, the next few are very unpredictable. But long term, over on many flips, it ends up being very predictable. And this is for coins. This is, we can do this for dice. We can do this for lots of things. But we can also do it for other things. Talking about, like, I could flip my cell phone, and what's the probability that the screen breaks? All right, it's not an easy 50-50 like a coin, but maybe I flip my cell phone and maybe on the first one it doesn't break, and the second one it does break, and then the third one it does break, and then so on and so forth. So over the short run, I may not be able to predict the exact result of any particular flip of my phone, but long run, it would settle into this, it would approach whatever that actual, like, long-term relative frequency, that probability is for that. And so it would kind of zero in on a number in that regard. So the probability of any outcome of a chance process is the number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. All right, that's probability. It's not, in the short run, we can't really talk, we think about probability in terms of short run, but what it really represents is that long-term relative frequency. And so in this case, the probability of flipping heads is on that coin is 50%. And we know that over the long run, 50% of those heads are flipped. 50% of those flips are going to be heads, the other 50% tails. Just to kind of understand it, randomness. The idea is that randomness is predictable in the long run, right? If we have the right situation. So unfortunately, our intuition about chance behavior tries to tell us that randomness should also be predictable in the short run. So we start to have this belief that, it was heads, the next one's more likely to be tails or something like that. It's going to even out in the short run. Like we have trouble combining the ideas. We know long term it's going to be 50%, but we think, oh, well, if we have a few heads and like in a coin, for instance, then all of a sudden it's going to be more likely to be tails anytime soon. And that's just not the case. What's the case is going forward from our point, even if I had 3 heads in a row, going forward, I still expect 50% head, 50% tails, long run. And so those 3 heads will just kind of ultimately even out. I'm not ever expecting to get 3 more tails to balance it out. I just expect it to be close to 50% the rest of the way. And eventually, if I do that long enough, it should average out kind of towards that actual proportion. So don't confuse those two ideas. It's really weird. People have a tough time kind of divorcing those ideas of, yes, long run, we expect it to be 50%, but in the short run, if we've seen whatever we, based on, regardless of what we've observed, it's still going to just be, 50% or whatever the portion is. If we're rolling dice 1/6, that we're flipping phones, I don't know, 70% chance or whatever it is that the screen cracks. Or if you're driving home from school, the probability that you get into a car accident is, whatever, 0.2%. Or any uncertain event, we can talk in terms of that long-term relative frequency. And so that's an introduction to the idea of probability.